YouTube, Electric Adventures here with the next video in Electric Adventures of the games, where I'm going through my classic games that I wrote back in the early to mid 80s originally for the original Spectravideo hardware and then later converted to MSX. We're doing Program Pack 7. Last time we did Skybase, so this time we have Quasimodo. And once again, absolutely no originality whatsoever. I basically coded this from a screenshot or set of screenshots I saw in the magazines for the Spectrum game Hunchback. It was also for the Amstrad too, I believe. Might have been for some other systems as well. So obviously all written in BASIC using Unisoft Startup. So drawing there, some bricks, a high score table, and a demo mode. So like the other games on this tape, fairly advanced in its having those extra little polishes. I suppose my sprite looks a bit like a Hunchback. Yeah, let's see how we go. So I don't think it's got as many levels as the original game, and our little soldiers down there look a little bit, shall we say, lacking. So the idea is you have to go over the pits and jump up and ring the bell. First screen is very simple. Next one, we're trying to avoid the spears coming up. Oh God. And we can make it all the way across there in a run, but I'm doing so badly. Deary me. This man, we'll make it good. We're gonna have to start again, aren't we? Put the old moniker in. Right. Let's try again. So, you know, it's trying to be quite colourful and it's got a few sound effects, so oh my goodness. Yay! Okay, so this time the fireball will get us if we're up in the air. Oh, I almost jumped into the fireball then. And the levels continue and mix and matching these different hazards. So now we have go. Oof. Oh dear, that was a bit silly. Went a bit too far. I did it again, didn't wait. Hey. Last life too, we've got a high score. Okay, we're actually about that. That's all the combinations. I'm not sure if this can actually get any harder other than maybe the speed of these. Well, right. So, as you can see, it's a fun little game. I never got to play the original game on the Spectrum or the Amstrad back in the day. I still don't believe I actually have a copy of ever the game for either, so So I just basically programmed this up from some screenshots I saw, you know, trying to get games that I thought looked interesting on my computer of choice. Alright, so that's the gameplay part. I'll get set up and we can have a look at the source code together. Right, so back, let's have a look at how long our code is. As I do apologise, I did compress code because it runs a little quicker and uses less memory. So like the other programs on this cassette, this is a reasonable size one. There we go, so 59 lines long, so obviously line 500 onwards are our sprite shapes. So we don't need to cover that when we get there. So 49 lines of actual code. Cool, that only just fits. So line 10 is all our setup. So we clear a bit of space, set our colours, our screen mode, make all the variables integer, which makes things run faster. We define our random function, seed it with time, and open our handle to the graphic screen so we can print text. Line 20, we set our colours again, clear the screen, we make Z a single precision, so that's giving ourselves some floating point accuracy there. It's probably for a speed counter. We restore 20, restores the data back to the start of the program. Line 30, we clear the screen, set colour 9, preset it at a point, put the string Quasimodo into A, and then we print that. It's interesting. Oh, I see, I'm printing it multiple times. Yeah, that's how you get the thicker text. You print it once, then you move the pixel one pixel down, one pixel to the right, and then you print it again, and it gets you thicker text. So we print that twice, we draw a line around it, and we put the Unisoft logo on there as well. And this is just while we're loading our sprite shapes. So line 40, we have 10 different sprite shapes, so we load those patterns in and set our sprite shapes, and then we reset our high score table, and the names against each one of them to just be dots. So we actually have a high score table that stores names. Line 50, we set our colours clear, and we do quite a complex draw command, which is probably our Quasimodo main logo, which is the large text you saw. So that would be that drawstring there. Quite interesting to look at drawstring. It's based sort of like on logo commands. So those that are familiar, just up, down, left, right, with distances and all sorts of interesting commands. For more detail, the command is explained fully in the link in my book, which is linked down below. Let's go 60 to 90. Right, so we draw that, and we actually have to draw it twice with an offset of 1 to once again get it thicker. Line 70, sorry that was off the screen a little bit, we draw a filled box, and then this logic here would be drawing the brickwork down the bottom. Line 80 does one more filled box, sets a position, and then puts our high score label, and then displays our high score table below that in a for loop, and then puts our press trigger for begin. Line 90 sets up a couple of variables and sprite. This is putting the sprites on the screen for our Hunchback, which would be made up of 2 sprites, his legs and his top. And we set, so we're using the on string, which is on a trigger press, go to a particular subroutine. So both of these are 120. So we're using an interrupt to detect the trigger press rather than just an if statement. So this is an advancement on previous games. And then we have our set loop where we're moving our Hunchback through particular things, and then he's going to jump over the hole, and then it's going to reset and go back. That's the start of that, but we'll continue on the next few lines. So there's another segment of the movement, and then another segment of the movement, and then another segment of the movement. So it's probably forward, first part of arc, second part of arc, and then we just go back around the loop again. So you can see that 110 go to 90. So just go continue the loop, and it's going to continue to do that until it gets a trigger event, and then it's going to go to line 120. We turn the trigger event off, so that's both for the keyboard button and joystick button 1, where it's the two we turned on. We clear the screen, we zero out our score. EM, extra man is our extra man multiplier, LV is our lives, SC is probably our screen, LL maybe is our difficulty level, we'll have a look at that later. We clear the player sprite off the screen, because remember he's already on the screen from the previous thing, which is set the Y coordinate using VPoke to 209, which is the quick way of doing it, and we do the same thing for all the other sprites to make sure none of them are on the screen. Probably a bit of a waste that actual for loop actually rubbed out the two sprites that I mentioned there, so there was a little bit of code there. And we set our sprite collision detection routine, so that's our interrupt when two sprites touch, is line 380. So remember that later when we get to 380. That can save a lot of time, rather than to have to spend a lot of time going through loops and figuring out what's being hit while you're playing the game. It's better to wait with basic to wait until two sprites have actually touched and then work out which ones. Unfortunately, it doesn't tell you which sprite has hit. Oh, that only just fit. Right, so line 130, we draw a large red box and we do our steps. So this is doing all our brickwork, probably the brickwork down the bottom, so that's fairly complex there. Line 140, we draw another box, we set our X position, our Y position, we go sub 440, which is probably putting our man on the screen. X position 1112 from 440, so we're putting, I'd say this is drawing the soldiers. It's our routine to draw the soldier, because there's 3 of them at different X positions. The current me would like to go back and tell the old me how to draw soldiers so they don't look so naff, but anyway. 150, draw another box. So this is probably drawing our score area at the top with the bricks. So we draw the whole thing, and then we draw another black box inside it to cut out for the scores. And that's line 160, draws that black cutout, and then puts our score, high score, and various things inside that box. Giving it quite a nice look. Okay, line 170, more line drawing, another black box, put our screen, set a whole lot of variables, which is our current X position, Y position, maybe the direction, not sure. We put our main sprite on the screen. Right, and then the next thing is, depending on what level we're on, SC is definitely our screen, then we put various sprites on the screen, probably for the arrows that are going to pop up, and then the next one will probably be the ones for that pop down. So 180 BO, interesting name for a variable, equals 200 sprite 20, that's probably the bell. I reckon that's the bell. And a little line, 4 is probably yellow, yep. If screen is 4 or screen is 6, then we probably put the arrows going down. Now 190, so sprite on, so we've turned our sprite collision detection on, and we're looking for, so J is obviously whether we're already jumping, so if we're not already jumping, then we allow our stick to move us left and right. So that's A equals 3 would be right, so we're increasing our X, make sure we can't go off the right hand side of the screen. Else, if A equals 7, that's left, we're moving to the left, and make sure we can't go off the left hand side of the screen. So all that one line does our left and right movement. If M equals 0, then so we're going to skip something if that M variable set, else if D equals 0 and D equals 1, then D equals 0, so that's flipping D between 0 and 1. 240. Right, M must be the, I've said missile, but it's actually that fireball, let's say. and whether it's going left or right, so it can potentially go left or right. That's interesting. And that would, yeah, line 210 would move that fireball across. Line 220. So if we're not jumping and the trigger's pressed, then we make j equals 1, which means we've started to jump. And what do we do there? We're setting. Oh, we're probably setting the new shape. So we're changing here him into the jumping hunchback. So we've got a different shape for that. We're saving M, whatever that was, and we're playing a little jump sound. And if we reach the right hand side of the screen, we probably reset our jumping motion, so we fall. Just trying to figure out what the next line is. BO is BO minus 1, so that's our bell timer. Yeah, so BO is our bell timer, so that's how long we've got to traverse the screen. Obviously when we get less than 20, it's going to start making a sound. And if we get less than 0, then it goes to 380. I take it we lose a life if we don't make it across the screen in time. There's no indication on the screen of the amount of time to go though. So 250, so j equals 1, we're jumping, we're decreasing our y, so we're going up in the air, and our x is going along depending on our jump direction, so j1 is our jump direction. So we move it up, and our sound is based on how high we are. So the sound will go like that. So line 260, j equals 2, that would be when we're falling rather than jumping. Going up, and we're increasing our y until we get down to, back down to the floor level. And if we are, then we turn off jumping and we stop playing our sound. 270, we're looking at a point on the screen and seeing whether there's anything underneath our feet, I would say, or whether we go into falling mode. And that's line 370. Line 280, so this is if our screen's not 2, not 5, and not 6, then we go to 300. So this is something that's only on those screens. Else BB equals BB, so we increase that if it's less than 8 minus, so the game does get harder. There we go. It does actually have some get harder logic. I'm just trying to work out what this is doing. BC times 4, 112. I think that's I believe that is the that's that fireball. I think that's the fireball. Okay, 300. So this is different. So if we're not seeing 3 and not seeing 5, then we go skip this section of code. So we've got our random function there. Puts by 5 effects. So it's sort of like a random thing. I was trying to figure out what was random in the thing. Can't work that one at the moment. So 310 is the continuation of that. We're doing a bit of movement there as my dog barks in the background. Line 320, it's more logic based on different scenes. So all this section going through here are the different actions depending on which screen we're on. And line 340, go to 190. It's actually the end of our main loop. So from now on, we should actually have our subroutines. So the 350 is printing our score, seeing whether the score's over our extra man barrier and giving us an extra man and increasing our lives, playing a sound. Line 360 is another subroutine. Actually prints our lives and see whether we've run out of them. Yeah, so it prints the little face character for each life that we have. Line 370 turns our sprite collision detection routine off, resets all our sounds. I'd say this is us falling. So we're falling down a hole because we've set movement of our sprite over A. Yeah, so it's definitely increasing the Y. So this is us falling down a hole and playing a sound. line 380 is, which the previous one just goes to. Our lives go down by once. This is where we go to when we lose a life. And if our lives are 0, we put game over, wait a little bit, wait for a key to be pressed, and then we go to 170, which is back to our title screen. 390 to 420. Okay, so 390 rubs all the sprites off the screen, checks our score for the high score, and see whether we've achieved a high score. So this is a subroutine we call, and if we've got a high score, it lets us enter our name. Line 400. Oh, this is using having a cursor where you've pressed the where you're currently entering on the screen. It's quite good. Goes around a loop there, and obviously exits when you press enter. So at 14, you can see it's looking for character 13, which is the enter key. And yeah, I think you can enter 12 characters. And if you get up to 12, it beeps at you, won't let you enter anything else. Just goes around the loop. Else increases the name, prints it on the screen, and goes round. Once we've hit enter, then we'll go to 420. If you don't enter anything for the name, it'll force you to enter something for the name. Else we'll clear the sprite off the screen, and then it will go through the high score table and see which one of the high scores we have set. And set the high score, and then go back to 50, but just back to our title screen. It's line 440, another subroutine, and this is the one that draws those ugly soldiers. Yeah, you can see line 450 is the circle for the head, and we put a couple of eyes on them and everything like that. So very basic soldier drawing. Line 460 is going to our next scene, increasing our score by the beat. So BO is the bonus. There you go. Sorry, slight interruption there. We're almost at the end. So this is our, we play some sound, or reset all our sound counters, but we play a little sound going from one scene to another. Well, ringing the bell. It's ringing the bell, that's right, making the bell go back and forth. And then we get rid of all our spot shapes. Oops, lost my focus. That's what happens when you get interrupted. 470 to 500. There we go. And we see if we're up to scene 7, so in other words there are only 6 defined scenes in this particular version. Then we go back to scene 1 and we increase our level of difficulty and go back around. And 480 goes back around anyway. And 490, for some reason I've got a catch-all loop there, so sets it in an infinite loop. And then we've got our sprite data. So it shows, I suppose, the concept of a multi-screen platformer, but also one where it reuses components. So rather than every screen, all of the logic being completely independent, it just has independent logic for each of the different things that can be on a particular screen. So in that respect, it's actually, you know, reasonably efficient. So that's Program Pack 7. Quite a good program pack in the quality of the titles and how complex they are, and also all show how you can do something in pure basic in all cases with those ones, without using any machine code. So it shows how powerful the Spectravideo and MSX machines were for that sort of thing. Alright, so I'll have to dig out Program Pack 8 for our next episode. I hope you're enjoying the series. I enjoy going back and looking at my original games that I wrote back in the day. And I get good feedback from you guys out there about these episodes. Alright, I'm Military Adventures. Thanks to all my subscribers. Thanks for watching, and I'll catch you next time.